Alright, hello everybody. Today we're going to be taking a look at a different problem. This is a problem that is an extension of a previous problem we did. Previously we covered a problem called the two-sum problem. This problem is going to be called the three-sum problem. So let's take a look at the problem and what exactly it's asking for. So given an integer array nums, let's say it's called nums, return all unique triplets, nums of I, comma nums of j, comma nums of k, such that I is not equal to j is not equal to k, and nums of I plus nums of j plus nums of k is equal to 0. Alright. So, for example, let's take a look at this code. This example. So, if we have the example of nums of -1, 0, 1, 2, -1, -4, the output should be something that looks like this. The reason being, -1, -1, and 2, they all add up to 0, and -1, 0, and 1, they all add up to 0. So that's the target. We're trying to find all of these a list of triplets, all the lists of triplets that add up to the number 0. It also can be customized to be a target sum. That's kind of what we did for the previous two-sum problem, where we found two numbers to add up to a specific target. The code for that isn't much different. We just replace the number 0 as the variable target that we set to, but in this case it's just going to be the number 0. So now let's take a look at kind of the step-by-step approach of how we tackle this problem. So let's say we have the numbers that look like this. Now there's two types of ways to do it. Usually when tackling a problem, we first look at the brute force solution. So let's take a look at what the brute force solution would look like. We could achieve a brute force solution by taking a look at a nested loop. So we'd have 3 pointers, for example. We'd start like I, j, k. Now this would be a nested loop, so it would be like 4i, 4j, 4k. This is kind of some pseudocode. K would be would always be j plus 1. K would always be j plus 1. J would always be I plus 1. And what we do is we check -1, we'd check -1, 0, 1. Are these all -1, 0, 1? You check, do they add up to 0? No. Then we'd move up k. We'd move k something like this. We'd move k to go to 2, and then -1, and then -4, and then we continuously check those things. We do the same thing for j, where we'd continuously loop over and over again these pointers, everything, using a nested for loop. So that would be the solution of how we could approach the three-sum problem, and we'd eventually get it. However, the time complexity of that is, in the worst case situation, to get all of these pointers to these last 3 numbers over here, that would take a lot of time. Like let's say these 3 numbers added up to 0. They don't, but let's say that they did. That would take a time complexity of big O of n cubed. Big O of n cubed. And that's what we don't want. So let's go back. A more efficient way we could do this is by approaching it using a different type of method. So the different method that we're going to do is we're going to start out by sorting this list. So we're going to sort this list first. And if you guys know are more efficient, you could like maybe someday I'll make a more complex guide for like specific types of sorting algorithms. But a sorting algorithm typically has a time complexity of n log n, not n log n squared. N log n is usually the time complexity of an n log. So we do a sort operation to get this list to -4, -1, -1, 0, 1, 2. So why are we going to be sorting this list? It is because we can do some different types of operations. Instead of having 2 pointers of I, j, k that would be continuously looping through this whole thing, we could do a specific type of binary operation to calculate this faster. So we'd have, let's say, a pointer I, let's say a pointer j, and what we could do is we can take this, the I and j, what we can do is we can also have a different pointer. Hold on. Okay, so slight modification here. We're going to be having I and then left and then right. So we're going to be having 3 pointers, just like how we had I, j, k. You could substitute left and right with j and k if you want, but in this case we're going to be doing having left and right. What we're going to be doing is we're going to be looping through this whole thing I incrementally, but what we're going to be doing for left and right is we're going to simply do the process of, if we add up I left and right as we did in the previous one, so we check I left right, we see do they sorry, let me make this clear. Do they all add up to 0? In this case they don't. For -1 plus 2, they do not add up to 0. So what we would be doing is we'd be checking them, what is their value. So -4, -1 plus 2, that's going to be a total of -3. And that is less than 0. So what we know is that since it is a sorted list, what we can simply do is we are going to be incrementing left up. So we're going to be checking left up, and what we know that is that when we're incrementing left, we know that this value is always going to be either bigger or the same. So in this case we're going to also include a condition to make sure that left keeps going automatically to the biggest value. So we're going to skip the duplicate value. We're going to have like a base code for that. We can also do it without the base code. It's simpler, but it's a little bit less efficient. So we're going to be skipping all the duplicate characters and going to the next highest thing, checking is this higher than -3? It is, but it's going to be -2, which is still not right. So we're going to be going up to 1, and then we're going to be going up to 2. And if we never find the value, then once we see that left and right are the same, we can simply switch I back, and we're going to be incrementing both I and j 1. So we're going to be incrementing these two up. And then we're going to be doing the same thing. And the reason this is way more efficient is because rather than looping through each thing over and over again, also I have to mention that for this value, we are going to be checking to see if, for example, the value was 3 for some reason. Like right now, let's take an example to make that more clear. Let's say we have this, right? Right now, the value of this is going to be, what is this? -1, 0, and 2. Let's say -1. I'm not making it super clear. But let's say this is -1, 0, and 2. We see that these add up to be 1, which is not 0. So in that case, what we would be doing is we would be decrementing right downwards. So with this strategy, what it does is it reduces the time complexity significantly. So this can all be done in a log n times n time complexity as well. So the total is time complexity for doing all of this is going to be simply n squared. So we're reducing the time complexity from n cubed down to n squared using this strategy of putting looping through this entire instead of looping through the entire string, just having these pointers continue sorting the entire array first, and then using this pointer method and systematically increasing or decreasing the left and right pointers and adding them to the I value, which goes through the entire loop once. So let's take a look at how that would work in actual code. So I'm going to switch back to the coding tutorial. So to start off with, give me just a second. Okay, to start off with, we're going to be defining our function, def3sumNums. We're going to, let's say we have this array nums here, for example. Actually, yeah, you guys already know what nums could look like let's say nums is there. We're going to be doing an operation to sort the list, nums.sort. We can make like our own personal function for nums.sort, but as far as I remember, Python uses the most efficient sorting algorithm as well, so it's always going to be an n log n complexity just doing this alone. So this is nums.sort that will sort the list how we had it previously, going from -1 0 1 4 1 2 -1 4 to -1 -4 -1 -1 0 1 2, all that. So we're going to be sorting the list. We're going to have the result array. This is what we're going to be returning as our final thing. It's going to be a blank list to start off with. Now what we're going to be doing is we're going to be looping for I in range to length of nums -2. Why are we going to be doing it -2? The reason being is that we have 2 additional pointers. Normally when looping through this entire thing, we would do for I in range to length of nums. But since we have 2 additional pointers, we know that I is only ever going to reach up until here, because left and right will be here. We're going to be having 2 additional pointers left and right at -1, -4. So we only have to have I loop until these first 4 variables. Next, we're going to make the code that skips over the duplicates. So remember how in the code, the problem here, we have I as like here, when I goes to, I is at -1 over here, we don't want to do the same exact calculation and let's say like left and right does its whole thing like going up all the way to each other. We don't want to have to do this whole thing where I goes to -1 and we have the same thing repeating over again. So what we want to do is make it so that I -1 -1 skips over all the way to 0. And the way we could do that is simply by saying this: if I is greater than 0, so we need to make sure that first it's at the second value, and nums of I is equal to I minus 1. Sorry. Sorry about that. I did some weird thing. Okay. Sorry. Okay. And nums of I is equal to nums of I minus 1. So what this is saying is that if I is greater than 0, so let's say we're at this stage, and we see that both of these numbers are the same, Then we just continue. And what continue does is it skips over this whatever all we have in the loop and goes back up here and just increments I by 1. So it's basically the equivalent of just skipping forward the pointer that we had in the list, for example. Now we're going to set two variables, left and right. We're going to set left to be I plus 1. Remember how we start off with left being the second value, not I, but the second value. And right is going to be the last value, length of nums minus 1. Just a reminder that these are the indexes, not the actual values in the list, the indexes in the list. Now we're going to say while left is less than right, while you're making sure that the middle value is less than the right value, what we're going to be doing is we're going to be calculating all the pointers. So nums of I plus nums of left plus nums of right. So this is doing the calculation for all the pointers to see what the total is. Now if the total is going to be 0, a reminder in this threesome problem, we're just going to be looking for the values that add up to 0. If you want to find a target, you can just simply have a parameter called target and set it to target. But in this case, we're going to stick with it just being calculating it for 0. So if the total is less than 0, then what we need to do is we're going to be incrementing the left pointer. Remember that? Like in the code. I don't know how long I was in the thing for. Else, if the total is greater than 0, we're going to be decrementing right minus equal 1. So these are the two outcomes of if we don't immediately hit the value that we're looking for. Else, now this is so total is less than 0, or total is greater than 0, or total is going to be equal to 0. We could just have it as the else condition, where we're going to first append result dot append. We're going to be appending the list of nums. This is, by the way, this is going to be a triplet, a triple set that we're going to be returning. So it's going to be a set of nums of I, comma nums of left, comma nums of right. So we're going to be appending that to the thing. Now, what we're going to be doing is similar to up here, how we did this function to continuously make sure that I is not going over duplicates. What we're going to be doing here is we're going to be doing the same thing, except for each of the left and right pointers. So we're going to say while left is less than right, and nums is of left is equal to nums of left plus 1, left plus equals to 1, while left is less than right, and nums of right is equal to nums of right minus 1, right minus equal to 1. So the logic, it'll take a little bit of time to explain, but essentially all you're doing is, if for example we see at this initial stage, like right here, when we're trying to move left upwards, we don't want to left to be -1 as well. We want it to keep going. So while left is less than right and nums of left is equal to nums of left plus 1. So if this is going to this, if you see that these are the same, we're just going to be incrementing it by 1 immediately. So that's what this the while loop we have there for are doing the same thing. And it's the exact same thing with the right, except in the opposite direction. Forgot the colons here. And at the end of this, once again, just to remind, to ignore what we just did there. At the end of this loop, if we see that that we found a match, we're going to be incrementing the left and the right pointers. I forgot if I mentioned that while drawing it out, but once we find the match and we have the match, all we need to do is make the left and right pointers go closer to each other by setting this, and I remains at the same spot. And at the end of this thing, we can simply just return the result at the end of the for loop. It's important to note that this is an n squared time complexity solution. Why? Because there's going to be this for loop and there's going to be a while loop inside the for loop. You might be asking, why isn't it n cubed when you have two while loops here? This is because, like I said, these while loops are specifically for skipping duplicate values. However, those duplicate values are going to be considered time skip time, like what do you call essentially a constant time operation, because you're only skipping over duplicate values which are within the list. That isn't an additional like time complexity thing. This is just simply incrementing left or right, similar to how it's done in this loop as well. So these things are just like an extension of the left and right loop iteration here. So this can all fall under one loop, essentially making a loop within a loop an n squared time complexity solution. Now we're going to be returning the result, and let's take a look. So if we have this value, I'll just paste it here for simplicity, and if we print 3sum of nums, we can run the code. Sorry about that, guys. Up here I had this error here where the parenthesis was in the wrong spot. It was supposed to be over here, because we're looping through I goes into length of nums minus 2. I was giving that explanation earlier that I totally forgot the parenthesis was in the wrong space. So now if we run this code, I think I did the same mistake somewhere else. Sorry about that. And we get all the lists of all the values that add up to the target of 0. So that's how we solve this code. Hopefully you guys understood the solution that I had. And yeah, see y'all next time.